Okay, today we are going to talk about exact differential equations. Okay. Actually, it's difficult to define what exact differential equation form is. So for us, we can define the exact differential equation as a following form. I'm going to write it on the board. Y x plus n y dy equal no, that's all. Okay, look at the presentation. A differential form is called exact if there is a function f at x and y such that satisfies the following conditions on partial f over partial x equals m x and y. Partial f of y equals m x and y. Okay. We have here these conditions and we don't know what we have, and which means that we have exact differential equation or not. But luckily we have the test for exactness, which is a form of the following equation. Thanks. Which means that a differential form, the differential form is exact if and only if the following condition is satisfied. And then we can write the equation as the form of dx plus n x y dy equals 0. Okay. Now, overall, we can say this kind of mathematical expression as an exact differential equation if the following condition, if this condition is satisfied. Okay. And then let's look at the solution algorithm. The first point, we have to write the differential equation in the form of this, which means the exact differential equation. And then, we have to pay attention with the negative signs all the times, which is the plus sign or the minus sign. For example, 2x dx minus 2y dy equals 0. We have this equation. Here, m x and y equals 2x, and n x and y equals minus 2y. So be careful with the negative signs. Okay, negative signs here minus 2y. And in order to determine if m x and y, the x plus n x and y is exact, we have to apply the test for exactness, which is this form. Partial m over partial y equals partial n over partial x. This is a test for exactness. Okay, it's called the test for exactness. And to solve this problem, exact differential equation, the first step is we have to consider the following. We know already this conditions f over partial y partial f over partial x dx 0 m x and y dx plus n x and y dy equals 0. So we have here m x and y equals what? Partial f over partial partial f over partial x. And n x and y equals what? Partial f over partial y. 1. So we are going to use these. And to find the f, the function f, we have to integrate m with respect to what? X. X. Plus c. But here I'm going to replace constant, this constant, 1. Because when the solving this problem, if we find this here, x, y equals 0. Okay? But here says there is a choice of either integrating m, x, and y with respect to x or n with respect to y. Which means that you usually use the easier one or you can pick the easier one first. And here I will assume that we start by integrating m to get f and x, y, which is the solution. Okay, I'm going to integrate this one and m, x, and y with respect to the x plus g at y.